Hi, today we are going to try to solve the question from LeetCode, which is a 48 um, question called rotate image. The main theory of this question, which we are trying to solve, is you are given a matrix n by n, which is a 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So you have to rotate the image in clockwise, which means you have to modify the input directly. Do not allocate another 2D matrix to do the rotation. So this is what the requirement is there for question. The most straightforward, simple way to solve it is would be that theoretically what we are trying to achieve is uh, this uh, column from the bottom to up should come up as a row which is from top from starting to end. The next column from a bottom to up should become a next row starting to end. And the next column from bottom to up should become the next row from starting to end. So what is the most simple way to solve it is that what we can do is we can have a matrix maybe of size n, which is the size of each length of each size. What we can do is we can create our own version of our matrix, allocate memory to it, read all the um, values from bottom to up, iterating through the whole matrix and placing them in the new matrix 7 4 1. Next, you would again go from down 8 5 2, it will become 8 5 2. If you go and check for 9 6 3, you can iterate in that way and add it to the newer version of the matrix. But the main thing which they asked us to do is it should be done in place rather than in uh, uh, allocating some sort of a memory to it. So, what is the most efficient theory to solve such kind of problems is that in mathematics we have few things called uh, transpose of a matrix and a reflection of a matrix. Transpose of a matrix means uh, we switch uh, 2 with 4, let's say 6 with 8, and 3 with 7. Then what we'll get is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is that movement, flipping the uh, elements along the line. Let's say the right line of reflection is the diagonal, and we just flip all the elements which are in diagonal part of it. So that is called transpose of a matrix. We have one more theory called uh, reflection of matrix. Let's say we take the center as the reflection, and what we can do is flip 1 with 3, 4 with 6, and 7 with 9. So what essentially we can do then is that we have few thing is we are first flipping each element in transpose. Next, what we do is we reflect each element of the transpose matrix along its center middle elements. It could become something like this and like this. So, what would the solution be? Then, uh, 1 would come to the ones place. The 4 which was here would come to here because of the reflection, and uh, 7, which was actually here, would have gone to here and would have reflected to here. So what we effectively would have gotten is 1, 4, 7. It happens the same for the second row too. What we have is 8 would have come to here, and 1, because of reflection, the 8 from here would be moving to 4. Same way in which 5, because it's in the center, it doesn't need to move or rotate, or in code it might rotate also, but it stays in the same place. Next would be 2. 2 would actually, what would happen to is that it got moved to the second row first element. After that, due to reflection, 2 moves from last element of the row to the first element of the row to the last element of the element. So effectively, a transpose and a reflect rotates the matrix in 90 degrees. So that is the fundamental theorem. Basically, that's the puzzle for solving the problem. So let's try to solve this problem uh, as we are trying to solve this problem. So yeah. So the basic theory is that we have a matrix which is of 1, 2, 3, um, 4, 5, 6, and 7, 8, 9. The answer matrix is that it's also of type 3, 7, 4, 1, 8, 5, 2, 5, 6, 3. So those are the what we are actually expecting. We have a matrix and we are expecting an answer which is of type this. We have a method called rotate, which is given, I think it's, if I remember it, yeah, it is written as rotate in the uh, method. And what we have to prove is that the matrix is same as the answer. So what are the common uses? Why are we trying to solve this puzzle? So this is used in many places where you want to do efficient rotations. The most common would be image rotations. Let's say you took an image which was in a landscape and you want to change it to portrait. So how do you do that? Or you have an image in portrait and you want to do it in landscape. So how do you solve it? So to do those things, this puzzle helps us to solve it efficiently. You can do it normally with a lot of memory allocation also, but this seems to be a better efficient algorithm to use and which is fun. So let's try to flesh out the whole problem. So we have a method called rotate. Let's cut it out and paste it somewhere here. Mm, and let's make this public, okay? Because in LeetCode it's also written as public. We have it in public. So first thing which we want to do for this matrix is transpose for the matrix. And what again, one more thing which we want to do is reflect, reflect for the matrix. So these are the two methods which we want solve to solve this puzzle efficiently. So let's try to flesh out the methods for these also. Okay, so now we have two methods called transpose. As you remember, transposing is reflecting of the elements along the forward left diagonal. So yeah, we are trying to solve that. And we have a one more thing called reflect. Once you transpose, you have to reflect it. Transpose, let's assume that int n is equal to matrix dot length, length um, for int uh, column column is equal to 0, column less than n, column plus this. So we are flushing out the top would be the column for int row equal to column plus 1 row less than n uh, row plus plus. So what are we trying to achieve? In temp would be equal to matrix row column. So we are storing that current value and it's just swapping the rate. It's like swapping algorithms. So then what we do is matrix dot row column is equal to matrix column row matrix column row is equal to temp. So that's how transpose of a matrix gets flushed out. So what we are fundamentally doing is uh, we are taking the first row. We are taking the first this element and swapping with this. Then we are taking the third element of this row and swapping with this. Then we go to this row. We start from uh, this sixth element and we swap it with 8. Then we go to the third row. We don't see any uh, additional element because there is no column row element which is greater than the column element. So the loop will stop. Transpose. Then we have reflect, which we want to do. Reflect is similarly like that only. What we are trying to do is we take 1 and swap it with 3. We take 4 and we swap it with 6. We take 7, we swap it with. We take 1, swap it to 11. We take 9, swap it with 1. Take 2, swap it with 10. Take 8, swap it with 4. Right. So yeah. So then, so the solution would actually be is that we have int n is equal to matrix dot length for int row is equal to 0, row less than n, row plus plus for int column equal to 0, column less than n divided by 2, column plus plus. So we are taking this. Now, how do we swap it? Let's first store this int temp tdn temp is equal to matrix row column. Then what we do is we take the matrix, we do row column is equal to matrix row nth element from the last cell, right? So size of the total, let's say if you wanted to get 0, get it from 0 column. So we are swapping the nth element, current element with the nth last element in the matrix. Then we take matrix row. Then we swap the nth element, which would be n minus 1 minus column is equal to matrix is equal to 10, right? We store it as 10. Yes. So now what we have is we are transposing the matrix and we are reflecting the matrix. Let me see this to clean it up. So yeah, we have implemented transpose and matrix. Let's hope that this solves the problem. Now let me test, play it and test. Yeah, so this seems to be working. So now let's try to add it to our main lead code. Take this, copy, paste. Okay, transpose. Let's run this here and say processing. So test case 1 passes, test case 2 also seems to be passing. Now let me submit this. So yeah, it seems to be working. So yeah, that's the solution for uh, rotate image. That's the theorem, and this is the implementation.